previous session, we have discussed about conductometric estimation. So now, potentiometric estimation. So today, this session we're going to discuss conductometric estimation, the next instrumentation experiment. So in your +1 or +2, we have done NaOH in the burette, HCl in the beaker. You have done volumetric estimation using phenol indicator. The end point was getting pale pink color, right? That is acid-base reaction or neutralization reaction. You estimated volume of NaOH required to neutralize the HCl taken in the conical flask. The same experiment can be done by measuring the conductance of the reaction. So what is the principle behind this? How does this work? Let us see one by one. So the main principle behind this conductometric estimation is Ohm's law. So what does this Ohm's law state? So Ohm's law states that the current I flowing through a conductor is directly proportional. This is the conductor. The current is flowing in this is directly proportional to voltage and inversely proportional to the resistance. That is, it is given here. I is equal to V by R. So here we are going to measure specific conductance. So what is specific conductance? So we have we're going to take two platinum electrodes of 1 centimeter square area and they'll be placed 1 centimeter apart. So if you're measuring conductance of the solution between these two electrodes, that is called as specific conductance. So I have two platinum electrodes, okay, and it will be placed platinum electrode size of 1 centimeter square area, placed 1 centimeter apart, kept 1 centimeter apart, and the conductance is measured between that. It is called as specific conductance. So what do you mean by conductance? So conductance or a conductance is a property, right? So conductance is a property of flow of electrons. That is in respect to solid. With respect to solution, so we're measuring the conductance of a reaction here. So each and every ion is having a mobility. Okay. So as if you ask 100 members to run, how many will get first prize? One person, second prize one person, third prize one person. So each and every ion is having a different mobility. That depends upon what is directly proportional to the size of the ion. If size of the ion is less, then mobility is more. If size of ion is more, mobility is less. Okay, if you ask the lean person and the fat person to run, who will run fast? The lean person will run fast compared to the fat person, huge person, isn't it? So similarly, when ions, the atomic size is less, then mobility is more. If atomic size is more, then mobility is less. So the conductance, how it is measured? Let us see the instrumentation over here. So here you have a conductivity meter. This is the conductivity meter over here. So we're going to dip a conductivity cell. The conductivity cell contains sealed platinum electrodes, which is placed 1 centimeter apart. This platinum conductivity cell is dipped in a solution whose conductance is to be determined. It is connected to the conductivity meter. Okay, and you will have a burette. In the burette, you're going to take a solution, titrant. Okay, and you're going to dip a stirrer, or you're going to fix it to a magnetic stirrer or a blow pipe. So when you add a titrant to the conical flask or a beaker, you're supposed to blow it. So when you blow, the solution will mix. So the conductance will be measured in the conductivity meter over here. So here we're going to do conductometric estimation. The major advantage of the conductometric estimation is we can estimate mixture of acids. So as I told you, NaOH versus HCl can be done volumetrically also, but this can be done, mixture of acids cannot be estimated. Only HCl can be estimated, or acetic acid can be estimated. Any strong acid or weak acid can be estimated. When you mix both the acids, can you estimate? It cannot be done because you're supposed to use two indicators. So the indicators may interfere in during titration of the other one, right? But here that will not happen. So we're going to take mixture of acids. So let us assume one strong acid, other one weak acid. So strong acid and weak acid. First, let us assume we're going to take HCl, the strong acid, acetic acid, the weak acid. We're going to mix both acids and try to take against NaOH taken in the burette. So first the strong acid will neutralize, later the weak acid will neutralize. So when you add NaOH, the strong acid HCl will neutralize. So HCl will react with NaOH to give NaCl and water. So once the entire HCl is neutralized, later what happens? Your acetic acid will come into picture. Acetic acid starts neutralizing. Acetic acid will start neutralizing to give what? Sodium acetate and water. So when you add, before adding NaOH to HCl, when you dip the conductivity cell, so your beaker contains H plus ions and Cl minus. So the mobility of H plus ion is much more, very very greater than mobility of Na plus ions. So initially the conductance will be very high. So conductance depends upon mobility of ions. Higher the mobility of ions, higher will be the conductance. Lower the mobility of ions, lower will be the conductance. So always conductance depends upon mobility of ions, and conductance is directly and conductance depends upon concentration of higher mobile ion. So when you compare H plus and Na plus, the mobility of H plus ion is more. So when you take a solution which contains H plus ions and Na plus ion, if the concentration of H plus ion is less, then conductance will be less. Even though the concentration, this is 1000 and you have only 10 here, since the concentration of H plus ion is less, the conductance will be less. So it's the other way around. If the H plus ion is more and Na plus is less, then conductance will be more. So always conductance depends upon concentration of higher mobile ion. That implies if the concentration of higher mobile ion is high, conductance will be high. If the concentration of higher mobile ion is low, conductance will be low. So initially the H plus ion concentration is high. So before adding NaOH, when you add NaOH, the high mobile H plus ion will be replaced by low mobile Na plus ion. Therefore, the concentration of H plus will slowly decrease. Therefore, the conductance also will decrease. So once the entire H plus ion is neutralized by NaOH, later we're going to add acetic acid. When you add acetic acid starts neutralizing to give sodium acetate and water. Okay. So later we're going to plot a graph of what conductance versus volume of NaOH. When you plot a graph of you get three lines. So three graphs, you get two lines. So you get one graph like this, another line like this, another line like this. We're going to extrapolate it like this. So the point of intersection, this gives V1, this gives V2. V1 is volume of NaOH required to neutralize HCl. V2 is volume of NaOH required to neutralize total acids, both HCl and NaOH. Whereas V2 minus V1 is volume of NaOH required to neutralize only acetic acid. V1 is volume of NaOH required to neutralize only acetic acid or HCl. V2 is volume of NaOH required to neutralize both the acids, whereas V2 minus V1 is volume of NaOH required to neutralize only acetic acid. You can see this curve. This curve represents decrease in conductance. This is for HCl. This is for acetic acid. And what is this? When you add, when both the acids are neutralized, what will happen? Extra add NaOH will remain in the beaker as Na plus and OH minus. So the mobility of OH minus is very much greater than mobility of Na plus. As the concentration of OH minus ion increases, the conductance also will increase. This is represented by this. Okay. So let us, so what are we going to do? So later, once you get V1 and V2 value, you're going to find out the normality and strength of HCl and acetic acid. You're going to substitute normality of HCl is equal to normality and volume of HCl. So volume of NaOH, normality of NaOH is 1, volume of NaOH taken is V1 from graph, volume of HCl is 50. When you substitute, we get the normality of HCl. So equivalent weight is normality of HCl into equivalent weight of HCl, that is 36.5. We get the weight of HCl present in the given solution. So next, when you come for acetic acid, normality into volume of acetic acid is equal to normality into volume of NaOH. So normality of acetic acid is equal to normality into volume of NaOH divided by volume of acetic acid. So normality of NaOH is 1, volume of NaOH is V2 minus V1, volume of acetic acid is 50. This we get normality of acetic acid. So if you want to know the amount of acetic acid present, so normality of acetic acid into equivalent weight of acetic acid. What is the equivalent weight of acetic acid? It is 60. So you get the exact value of strength of this one. So let us see a small demonstration how to perform the experiment over here. Acid mixture. So when the mixture of acids, that is HCl and acetic acid, is mixed in equal quantities, are going to estimate mixture of acids. So we take mixture of acids 50 ml in this and NaOH in the urine. So we will take the conductivity cell and connect it to the conductivity meter over here. We will add NaOH in increments of 0.5 ml. So as I discussed earlier, when we add NaOH, first the strong acid HCl will get neutralized. So later the weak acid will get neutralized. So initially the conductance will decrease when HCl gets neutralized. So later, when acetic acid starts neutralizing, conductance will increase. When both the acids gets neutralized, the conductance will increase rapidly. Let us see how the values will increase and decrease. To start with, going to, before adding NaOH, the zeroth reading is 29.3 per mole per centimeter. So we are going to add 0.5 ml of NaOH. We are going to add 0.45 ml of NaOH. HCl gets neutralized. So the value is 20.6. So similarly, we are going to add 0.5 ml, 0.5 ml, 0.5 ml and continue until increasing in 1.0, 1.0 difference. But here increases more than 1.0. When this happens, this is because of increasing concentration of OH minus ion. Because know that conductance is directly proportional to the mobility of ion. 4.5 ml of NaOH. HCl gets neutralized. So the value is 20.6. So similarly, we are going to add 0.5 ml, 0.5 ml, 0.5 ml and continue until the conductance increases rapidly. Sure. So we are done. We have added in increments of 0.5 ml. You can see the decrease in conductance is decreasing slowly. So HCl is getting neutralized. Okay. So once HCl is getting neutralized, the conductance is decreasing. Later it starts increasing here. You can see it's increasing the increments of 1.0 per mole per centimeter. So here it is because acetic acid is getting neutralized. When both HCl and acetic acid is getting neutralized, now the conductance increases rapidly. You can see here. So it is increasing in 1.0, 1.0 difference, but here it increases more than 1.0. When this happens, this is because of increasing concentration of OH minus ion. Because know that conductance is directly proportional to the mobility of ions. So here the concentration of OH minus ion increases. As the concentration of OH minus ion increases, conductance also will increase. Therefore, there is rapid increase in conductance once both the acids are neutralized. Once it increases rapidly, take 4 more readings and stop the experiment. Plot the graph of conductance versus volume of NaOH and determine our endpoint. So when you plot a graph of conductance versus volume of NaOH, we have the graph comes like this. This is the graph. So you have taken conductance here, you have plotted volume of NaOH here, you have got two endpoints V1 and V2. So V1 is volume of NaOH required to neutralize. V1 is volume of NaOH required to neutralize HCl. V2 is total volume of NaOH required to neutralize both the acids. So how to determine the volume of NaOH required to neutralize acetic acid? That is V2 minus V1. 5.0 minus 2.5. That gives V2 minus V1 gives volume of NaOH required to neutralize acetic acid. So V1 is volume of NaOH required to neutralize HCl. V2 is total volume of NaOH required to neutralize both the acids. V2 minus V1 is volume of NaOH required to neutralize only acetic acid. Once we plot the graph, we will go for the calculations. So we have once you have completed plotting the graph, so using V1 value, V2 minus V1 value, we are going to do the calculation to determine the strength of acetic acid and HCl. So in order to determine the strength of acetic acid or the weight of acetic acid and HCl present, we are going to calculate the normality of HCl and acetic acid first. So in order to calculate normality of HCl, we are going to use the normal formula N1V1 equals N2V2. So normality of HCl equals normality into volume of NaOH divided by 50. So volume of NaOH is V1 required to utilize HCl. We are going to get from graph it is 2.5. Okay, we are going to substitute that value here. Normality of NaOH is 1 normal. So volume taken as instead is 50. We get 105 normal. So weight of HCl per dm cube is normality of HCl into equivalent weight of HCl. The equivalent weight of HCl is 36.5. When we multiply, we get it as 1.82 gram per kg. So similarly, we are going to calculate the normality of acetic acid and determine the weight of So we can